Mathematical representation of real-world situations. Welcome, everyone. Today, we are going to explore how we can use mathematics to represent and solve real-world situations. Now, think about the problems you encounter in your daily life. Often, we face complex scenarios that are a bit too complicated to be solved using just simple addition, subtraction, multiplication, or division. To tackle these more complex problems, we use a very important process called mathematical modeling. You can think of modeling as building a bridge between the real world and the world of mathematics. Essentially, this process involves taking a word problem, something written in plain, everyday language, and translating it into a mathematical equation. It's like translating a sentence from one language to another, but instead of English, we are translating it into the language of algebra. As we move through today's lesson, you will see that when the relationship between the different parts of a problem involves a squared term, we represent that specific situation using a quadratic equation. This will be the foundation for the step-by-step process we are about to dive into. Step-by-step process of modeling. Now that we understand what mathematical modeling is, let's break down the actual strategy you should use every single time you face a word problem. I want you to think of this as a four-step roadmap to move from a confusing paragraph of text to a clean, solvable equation. Step 1 is all about identifying the unknown and assigning a variable. Before you start writing any math, read the problem carefully to figure out exactly what the question is asking you to find. Once you've identified that unknown quantity, assign it a variable. We usually use x for this. But here is a crucial tip. Don't just write x. You must clearly state what x represents. For instance, you should write, let the width of the rectangle be x meters. This keeps your logic organized and prevents confusion later on. Step 2 is where we start building our expressions. Now that you have x, look back at the problem for any relationships mentioned. Your goal is to express all other unknown quantities using that same variable x. For example, if the problem says a length is 5 more than the width, and you've already defined your width as x, then you can mathematically express the length as x plus 5. Step 3 is where we establish the mathematical relationship. This is the bridge between your expressions and an actual equation. Look for a core condition or a formula that connects the quantities you've just defined. This might be an area formula, the product of two numbers, or even a total cost. Once you find that connection, set up your equation. Finally, step 4 is to simplify everything into standard form. At this stage, your equation might still have brackets or terms scattered on both sides. You need to expand any brackets and move all terms to one side so that the equation equals 0. Your ultimate goal is to reach the standard quadratic form, which is a x squared plus b x plus c equals 0. Once you reach this form, you are officially ready to use your quadratic solving techniques, which we will see in the upcoming examples. Illustrative examples. Now that we have understood the theoretical steps of mathematical modeling, let's put them into practice with our first concrete example, which is a geometry application. Take a look at the scenario presented here. We are dealing with a rectangular plot of land. We are given two key pieces of information. First, the total area of this plot is 528 square meters. And second, there is a specific relationship between its dimensions, where the length is 1 meter more than twice its breadth. To solve this, we will follow the four-step process we just discussed. Step 1, assigning the variable. To begin, we need to identify our unknown. Since the length is described in relation to the breadth, it makes sense to let our variable, x, represent the breadth of the rectangular plot in meters. Step 2, expressing other quantities. Now, we look at that relationship I mentioned earlier. The problem states the length is 1 meter more than twice the breadth. Since we have defined the breadth as x, we can mathematically translate twice the breadth as 2x and 1 meter more as adding 1. Therefore, our length is expressed as 2x plus 1 meters. Step 3, establishing the relationship. This is where we connect our variables to the known area. We know from our geometry formulas that the area of a rectangle is equal to length multiplied by breadth. We are given that the area is 528. So, we can set up our equation by multiplying our breadth, x, by our length, 2x plus 1, and setting that equal to 528. This gives us x times, open parenthesis, 2x plus 1, close parenthesis, equals 528. Step 4. Simplifying to standard form. To make this a proper quadratic equation, we need to expand the brackets and set the equation to 0. When we distribute the x, we get 2x squared plus x equals 528. Finally, to reach the standard form we saw in the previous slides, we subtract 528 from both sides. This leaves us with our final quadratic equation, 2x squared plus x minus 528 equals 0. We have successfully translated a real-world word problem into a mathematical model. In the next slide, we will see how this same logic applies to a problem involving number theory. Illustrative examples continued. Now that we have seen how to apply this to geometry in our first example, let's shift our focus to a different area of mathematics, number theory. On this slide, we have example 2, which is a number theory application. The scenario presented is quite simple. We are told that the product of two consecutive positive integers is 306. Let's walk through the solution breakdown together, following the same 4-step modeling process we discussed earlier. Step 1. Assign the variable. First, we need to identify our unknown. Since we are dealing with two numbers, let's start by defining the first positive integer as x. Step 2. Express other quantities. Now, we need to describe the second number using that same variable. Because the problem states the integers are consecutive, we know they follow one after another, like 5 and 6, or 10 and 11. This means the next integer is simply one more than the first. So, we can express the second integer as x plus 1. Step 3. Establish the relationship. This is where we translate the word problem into math. The problem uses the word product, which tells us we need to multiply our two terms. Since the product is 306, we set up our equation as x multiplied by the quantity x plus 1 equals 306. Step 4. Simplify to standard form. To make this a proper quadratic equation, we need to expand the brackets. Multiplying x by both terms inside gives us x squared plus x, which equals 306. However, as we learned in our step-by-step guide, we cannot stop here. We must move all terms to one side so the equation equals 0. By subtracting 306 from both sides, we arrive at our final result. X squared plus x minus 306 equals 0. So, the final quadratic equation representing this situation is x squared plus x minus 306 equals 0. As we move to the next slide, I want you to pay close attention, because I'll be highlighting some common pitfalls where students often trip up during this translation process. Common mistakes to avoid. Now that we have seen how to successfully model geometry and number problems, I want to pause and discuss some common pitfalls. Even if you understand the logic, small errors in these steps can lead to the wrong answer. First, watch out for incorrect variable assignment. It is a very common mistake to jump straight into the math without defining your terms. Never forget to explicitly state what your variable represents. Always write out, let x be, followed by your unknown quantity. If you don't do this, you might find a numerical answer at the end of your calculation, but have no idea if that number refers to the length, the width, or the area. Second, be extremely careful with your translation from English to algebra. Phrases like more than or less than can be tricky. For instance, if a problem says 5 less than x, many students mistakenly write 5 minus x. However, the correct mathematical translation is x minus 5. One small slip in translation can change the entire nature of your equation. Third, do not stop your work too early. A frequent error I see is students leaving their equation in a factored or unexpanded state, such as x multiplied by the quantity x plus 5 equals 300. While this shows the relationship, it is not yet a proper quadratic equation. To complete the modeling process, you must expand the brackets and move all terms to one side so that the equation equals 0, resulting in x squared plus 5x minus 300 equals 0. Finally, always keep an eye on your units. In real-world scenarios, like the area problem we looked at earlier, you might encounter measurements in centimeters and meters in the same problem. Always ensure all measurements are converted to the same unit before you begin forming your equation. In our final slide, we will summarize the essential workflow to keep in mind for all your future modeling tasks. Key takeaways. First, remember that modeling is essentially the bridge between the real world and mathematics. It is the systematic process of taking a complex word problem and converting it into a clear mathematical expression or equation. Second, never underestimate the importance of variable definition. As we saw in our step-by-step guide and our examples with the rectangular plot and the consecutive integers, the very first and most crucial step is to clearly state what your variable represents. If you don't define your x correctly at the start, the rest of your work will be difficult to interpret. Third, always aim for the standard form. Whether you are dealing with geometry or number theory, your goal is to manipulate your equation until it reaches the required final format, which is a subscript x squared plus bx plus c equals 0. This is the standard form that allows us to use our quadratic formulas effectively. Finally, keep this logical flow in mind as a roadmap for every problem you encounter. Start with identifying the unknown, move to creating an expression, establish your equation, and finally, simplify everything into the standard form. All right, we have reached the end of our lesson. Before we wrap up, let's quickly recap the key takeaways to ensure you have a solid grasp of how to represent real-world situations mathematically. If you follow this sequence, you will be able to tackle even the most complex word problems with confidence. Great job today!